Davis. I'm with the Marine Corps Warfighting Lab, the aviation branch head in the Science and Technology Division. And the two technologies that you see here today are the Mars, which is a modular arm robotics system, and then the Ferret, which is another robotic system. Both robots basically provide a capability to provide surveillance, detection, reconnaissance, that type of deal for our forces. They're meant to augment the Marines. They're not a replacement for our Marines on the ground. And with the Ferret in particular, its main mission when it's loaded up with the technology, which we don't currently have on it, is to go into a building and basically start mapping out that entire building. And it has a level of autonomy where it can kind of go in and do that itself. It has a LiDAR capability, which is a system that can help map that building. And what it really does for our Marines is provide them before having to go in the building, it provides them a map of what that interior of that building is going to look like. So which is really great for when they're doing mission planning or so forth, to be able to know what they're going to go walk into. The Mars is an arm system. What you see on board is a M240. It's a 7.62 machine gun. Standard for what our guys carry. It's meant to augment the team. So they're going to go forth, the infantry patrol, and this robot will be with them. And maybe the guys don't want to go, maybe you don't want to send your Marines first in the door or down an alleyway. You know what? They can send the robot down. The robot can go down that alleyway or go in that doorway, see if there's a threat in there, and let the Marines know who will be controlling the system. And if they want to prosecute the system, that takes the human in the loop to be able to actually execute that. Just want to emphasize that these technologies, the Mars in particular, are a little bit older. We're working more advanced systems where there's the level of autonomy is already built into where they can actually go. You just tell them where to go, maybe on a tablet, and they go out and execute the mission themselves and perform back, so you don't have to actually control it the entire time. Currently, in this configuration we have here today, it's controlled via a controller, and you can't really be more than 800 meters line of sight with the existing system. Anyone can control it. So these systems aren't designed to have someone that's super well trained in it. We wanted to make it as easy as possible so that it can be organically inserted in with a Marine unit. So hopefully our goal is to be able to have a system that takes no more than a short amount of training and say, hey, go out and execute this, and they can do it real easily. So they don't need an additional specialty, no additional extra MOS training, just a few minutes of learning how to do it, and then they can actually go out and execute that mission.
So what you're going to see is
the thermal one, right?
It is. So what you'll see is the circular field of view there. The green is your typical night vision, and the inset, the little rectangle, that's your thermal. So that's detecting the body heat of all these gentlemen here.
That's pretty sweet.
Yeah, it's really neat. So as you scan around, even if targets are obscured, if there's smoke, this will penetrate smoke. If they're hiding in vegetation, because it's all based on your heat. Yep.
That's pretty sweet. So that's not even washed out on regular sunlight either.
So the thing about this is we actually have a tiny little pinhole here. So we're limiting the amount of light that comes in to try to mimic. I mean, it's not exactly mimicking, but reduce the light greatly to show you what it would look like at night. Yeah.
That's pretty cool. And they can't get surprised if someone tries to flash them in the eye with it.
Right.
That's pretty cool. Thank you.
Thank you very much, sir.
Let me get the...
towards the passenger door. Ho! All right, if you just want to go ahead and like make the turret spin and stuff like that, so we can see like you actually operating it.
Okay, turret spinning. Still kind of close.
Yeah, I just want to see if the shotgun's gonna pick you up.
Okay, can you hear me now?
No, I think what I'm gonna do.
Move it this way.
No, I have another mic. I'm gonna mic.
Pan, tilt, harv, day, night camera, and you can see if I go up here to my, that's my day camera, and that's my night thermal camera.
Eyes right here, those are the front camera.
Roger that.
Marines, today we're at Gulf 27 doing a robotic target demonstration for the commanders across the division. The targets are able to react in different ways depending upon what you want them to do.
These robotic targets will help bridge the gap between training and combat by creating a more realistic live fire experience.
These targets are available for you to use on Camp Lejeune. We need your feedback on how we can make these better and how it's going to better suit your unit to use these.
DC is a robotics complex breach concept, and basically the complex breach is one of the most dangerous missions that a maneuver element can undertake. So what we're trying to do is find ways to execute that same breach, that same maneuver, using robotic systems. What we're doing is actually taking surrogate systems, so things that we wouldn't actually employ on a battlefield, but things we can roboticize. So we've got lots of kind of new prototype technologies that are out here, and to try the concept out and see if it works.
RCBC is what we call a focused assessment. The focused assessment falls underneath a process that we manage in Strat D called the Arctic Live Prototype Assessment. A focused assessment is done on an as-needed basis. They're usually smaller than an Army or an Arctic Live experiment in AOE, but in this particular case, this is a major effort, so it's actually a little larger. But this one is a crawl, walk, run approach at a risk reduction event for what we hope to be the future joint warfighting assessment opportunity where we can wrap the capability into the event itself.
Well, right now we're really focused on getting soldier feedback. All the systems, we get soldiers that are trained on them, and they're going to operate them, and then basically get their feedback. So the ones know how the systems and technologies work best in terms of what we have today, and we're looking at these new systems that we're bringing the vendors in here to play with, and based on the soldier feedback that we get, it looks like it's a viable concept, and we'll be able to either put money into or continue developing that capability, bring it to another iteration of this event.
TARDEC served as the lead systems integrator for the RCBC. We got soldier feedback, which is always excellent. They can tell us the things that we don't see inside of the lab or in our own limited tests. The feedback from events like this helps TARDEC understand what the actual requirements are, since everything that we build is based on requirements. And so we need to understand this is what's nice to have, this is what is required, and if we are able to couple together these capabilities into single platforms or maybe a couple of platforms that all interoperate, we're able to do all the things that we want to do both operationally and technically.
Part of the experimentation that we are doing is force on force soldier based. What we have are developing concepts, and we are looking at the key elements of those concepts that make them work and put these either prototypes or surrogates in the hands of soldiers We allow the soldiers to execute them, but we're also trying to ensure that the Army has its science and technologies, future investments pointed in the right direction.
This is a data point in the larger campaign of learning, and so it's all about getting systems out to the field rapidly so that we can experiment and then taking them back into the lab so that we can make them even better.
So essentially, what are the things we need to learn about whether it's new subsystems, new technologies, capabilities? How do we define those and better inform the future development, the future Army, things we're going to need to fight those battles? It's hard to know what the battlefield is going to be like in 2025, 2030. So we try and forward think as much as we can using intelligence. Obviously, we need to know what the threat's going to be because our Army is threat focused. So looking at major threats or near peer type threats. So we got to figure out what it is that they're doing and find ways to counter that. Also, how do we maintain an overmatch? How do we, as an Army, maintain enough capability that we know we're going to go into a fight and we're going to win it? Failure is an option here because it allows us to figure out what works and what doesn't work. Because this isn't the end state for us. The intent is to actually just try some new concepts out. If they work, great. We'll continue to develop them and try and get a better capability out of it. If not, we'll look elsewhere.
Trying to do a manned-unmanned teaming. We brought two technologies: the MUT, which is multi-utility tactical transport, and that is a 4x, 6x, and 8x that carries load and kit for the guys. It can carry payloads, and it provides expeditionary power. The other technology is a robotics applique. We have it on the amphibious assault vehicle, and that provides teleoperation and leader-follower technology. This event provides relevant troops, tasks, terrain, and threats for our technology to kind of quickly go from, is it the right answer or is it the wrong answer? You fail quickly and you proceed quickly. The benefit, the teaming that we're really going after is three types: persist and protect and project the force. The underlying theme is to preserve the force. There's only so many warfighters that we have, Marines, sailors, and we need to preserve them and then multiply them.
My name is Greg Kriefel and I work for Robotic Research. This unit is the MUT, and our company has developed the autonomous mobility system that allows it to autonomously navigate operator-generated routes. We can also teleoperation, remote operation of the robot through the OCU, getting direct video feedback to allow the operator to determine where it should go. So the primary sensor on the autonomous navigation system is the LiDAR. What it does is it sends lasers out across the environment. Those lasers bounce off of obstacles and create a very detailed point cloud to determine where it can and can't navigate. I think that's the most rewarding part in the whole effort, is seeing it behave very characteristically well.
Today, what we're doing is a final exercise. For the past 6 weeks, these Marines of Kilo 35 and McWill have trained to the technologies that we're integrating. So at the Marine Corps Warfighting Lab, we test and evaluate future concepts and technologies. We have a concept-based experiment that we're doing. We have over 40 technologies here with the CLT Kilo 35. Some of them range from 5 unmanned ground vehicles to 5 unmanned aerial systems. We're looking at technology that reduces logistics, which we have termed logistics demand reduction. Now we have unmanned ground vehicles which can actually carry 240s and 50 caliber weapon systems, and it can be right next to a foot mobile company. So now we're bringing weapon systems that are not normally foot mobile to the company itself. We have 5 unmanned aerial systems that we're going to be playing with. One of them is the Black Hornet. It's about 4 inches long. It is brought down to the squad level. This thing cannot be heard after it goes above 30 feet. So you basically can peek around the corner without the enemy knowing, and you can see what is around the next corner for that squad leader to know. The small quadcopter that had been flying around is called the Instant Eye. It has 3 cameras that allow it to see straight ahead, 45, or straight down. you can reach out and see what's coming at you and what you can be expecting here in the next 100,000 meters. The 40 technologies that we're experimenting with will make the Marine Corps more efficient, more lethal, and more survivable. So ultimately what we want is the first person or first thing in the door is a robot to get SA into what's around the next corner.
I was gonna tell her to put it on and get some. Make sure you crank down the other way.
Yeah. I know they advertise the old, but the old.
What is my platoon going to be doing? No, what's your scenario? Right now we just know that there's a D bid. And one thing that we're going to be doing on the brown van is trying to use the...
We had different cameras pointing at different locations and our speed and trying to view the image as we were driving, checking for stuff, indicators.
Something like if we're pulling back evidence or whatnot, we won't be able to do that cursory, secondary or tertiary check. So, but you can write one huge window. Cool.
Yeah. Try it. No, I'm sure there's one on the back.
Right back. I was just wondering, like, when we rode up, this is all new to me, like, the language support. Like, when we
No, yeah.
Up for it, like,
guys moving with their weapons in front, moving down the road towards us now.
She was videotaping the guys come out like.
Yeah, I've got just a few.
Should be good right now. We just charged the battery back up.
So it's saying he doesn't have a video.
So we're just going to have them use one per squad. So, do you have them set up? Can you break them out real quick so
Sure.
we get them to pick them up?
Oh, yeah.
The weapon station, you want this power on the whole time. If not, you want to turn it off because she'll draw power on that. So if I go look at your state of charge again, right here, I don't want to get up there. So this is pretty
45
cool.
is pretty hot.
That's pretty hot.
That's when you gotta start lifting these up.
Yeah, the batteries will get hot. Into the the 50s, then you got to start thinking about when. This is an enabler. It's a force multiplier, and it'll preserve and combat power, from a safety standpoint, but it'll also allow them to cover more area, larger area of influence. It'll let the current force do more, cover more area. Lightening the load, they can offload it on here, they can get the objective, they're not tired, they could have more ammo, they can fight for 72 hours with this. They could load this up and then fight for 72 hours without resupply. So it allows, I think it's going to enable them to complete their mission that they're going to be given for this expeditionary, like the company landing teams. It's going to help make that possible because they're limited in the airlift that they can put in, but they still have to fight, they have to have their gear. So I think it's an enabler for the upcoming missions and the expeditionary profiles that they're looking at. This is the General Dynamics Land Systems Multi-Utility Tactical Transport, or MUT. Okay, so yeah, so this is the tracked version of the 4x4. You can swap out wheels. The wheels are also effective. The tracks are good for floating on mud and snow and sand. And there's also a 6x, so 6 wheels, 6 driven wheels, and then an 8x, which is 8 wheels. And those are really filling the gap filled by the original M274 mule. The purpose of it is to help dismounted warfighters by carrying load, letting them offload equipment, or carrying large, more capable weapons like this, where it would take 5 people. One person can get a 50 cal downrange. So the idea is to provide, lighten the load, and then expeditionary power. People are always running out of power in the field. This will allow them to bring more gear, more batteries, or a charger to charge up their batteries.